Hi everyone. So today we're going to be talking about systems of equations and how to solve them. Today we're only going to be looking at the addition method, and those are the only examples that you will be asked to work on. So let's get started. So before we go into solving systems of linear equations, we're going to talk about what they actually are. Okay, so a system of linear equations consists of two or more linear equations. So we haven't necessarily spoken about what a linear equation is, but it is an equation that when you graph it, it is a line. Hopefully it'll look familiar from stuff that you've done in the past, y equals mx plus b. So we have two of these equations, y equals negative x plus 4, and then y equals x minus 2. So this is considered a system of linear equations. And remember, you need equal signs. And to make it a linear equation, you need x and y. And there can't be any exponents here. Well, any exponents bigger than 1. Okay, so the solution of a system of linear equations is any ordered pair that solves both of the linear equations. It is where the lines intersect on the graph. So I just want to talk about this first part really quick. Any ordered pair that solves both linear equations. So that means if we were to take this ordered pair here, 3, 1, so x is equal to 3, y is equal to 1, and plug it in for x and y, it would make this equation true. And we're going to take a look at what that's going to look like. It also is where they intersect on the line. So here we have these two equations. They intersect at this point, 3, 1. So that point where they intersect, that is the solution, also called the point of intersection. So there's several ways to solve these. You can graph them. You can solve them algebraically. Normally, you're asked specifically a method to use, so we have to be prepared to use all methods. So today we're going to be using addition. Okay, so before we actually solve one, I just want to talk about the different kinds of solutions. So these are the 3 different scenarios that can happen, where we have 2 lines that intersect at one point. When we have that, that is one solution. So there's only one point that'll make this true. Okay, there's another scenario here, the second one, where we have lines that do not touch. Those are called parallel lines. And because they do not cross at any point, there is no solution to that system of equations. The third scenario is where we have 2 lines that are layered on top of each other. So think like one is laying on top of the other. So that means they are the same line. So that means they are infinite solutions. There's an infinite amount of points that'll make that system of equations work. Okay, so let's get started. Additive inverses. So this is a word that's going to be coming up a lot in this unit. Additive inverses. Hopefully you remember that from when we did number properties. But additive inverses are 2 terms added together whose sum is 0. Also known as the opposite of a term. So for example, if we have 4x, the additive inverse here, the opposite, is negative 4x. Okay, so all we did was take that positive 4x, make it negative. Another example, if we have y, the additive inverse of that is negative y, and vice versa. So this really can go both ways. Let's do one more. Say we have negative 3a. The additive inverse of that is positive 3a, and vice versa. So it's just the negative of a term, because when we add them together, you get 0. They cancel each other out. So 4x plus negative 4x, that's equal to 0. Okay, so we're going to go step by step for how to solve these, because they can get a little involved. So we're going to be solving this system of equations. We have negative 4x minus 2y equals negative 12, and then 4x plus 8y equals negative 24. In this case, we do have inverses, so we're going to use this method only when we have inverses present. All right, so the first step is to identify a pair of inverses. So we are going to take a look at our 2 equations and say, okay, which 2 terms are basically almost exactly the same, except one is positive and one is negative. So that means they need to have the same number, except different signs, and the same variable, that same letter. So we can't have negative 4x and 8y be inverses because 1, they don't have the same number, and 2, they don't have the same variable. So hopefully you noticed we have this negative 4x and that positive 4x, which was very similar to the example that I gave before. Those are our inverses here. It's really, really important to identify these first because that's going to help us solve the rest of this equation. All right, so now once you identify those inverses, we are going to add these equations together and we're going to cancel those inverses out. Because like we mentioned before, when you add additive inverses, the sum is 0. When you add them together, they get 0. So these cancel out, and then you add everything else that's left. So we have negative 2y plus 8y, that gives us 6y, equals negative 12 plus negative 24. Same signs, add and keep, you get negative 36. So we have 6y equals negative 36. Which looks a lot easier to solve than what we originally had. That's the entire purpose of this method. It's called elimination because we're eliminating a term. So we only have one term, one variable left to solve for. So that's our next step, solve for the other variable, so the one that we didn't cross out, and it's y in this case. Okay, so to solve for y, we're going to divide by 6 on both sides for those to cancel out, and we get y equals negative 36 divided by 6 gives us negative 6. So that is our first solution, y equals negative 6. But when you look at a system of equations, we see that we have an x and we have y. So that means we only solved for half of this question. We need to solve for x also. So the next step is we are going to substitute the variable that we just found, which was y, into one equation to solve for the other variable. So we're going to choose between one of these equations, and it does not matter which one. And I'm going to just separate it out, and we're going to substitute. Okay, so I'm going to go with this bottom equation. I see that there is not as many negative numbers, so that's the one that I'm going to go for, but it does not matter. You can choose either one, you'll get the same answer, as long as everything else is right. So I'm going to just rewrite my equation. And we are going to, like we said, substitute the found variable into this equation. So we solved for y. That means we're substituting in for y. Please don't solve for y, take that number, plug it in for x. Y and x are two different variables. So if you solved for y, you have to plug in for y. So instead of writing y, I'm going to write negative 6. And then everything else stays the same. I'm going to bring everything else down. So I have this 4x plus 8 next to the y equals negative 24. And then we solve from there. So we're going to multiply this 8 and this negative 6 first, and we get negative 48. I'm going to bring everything else down. Now we're going to add 48 to both sides. That cancels. I'm going to just bring this up here now. So those canceled out, and we were left with 4x equals negative 24 plus 48 gives us 24. Different sign, subtract. And then last step, we divide by that number in front, which is 4. So we get x equals 6. So if you end up with something like y equals negative 6 and then y equals 6, you did something wrong because we need an x and we need a y. So the last step is to write our answer as an ordered pair. So remember it's x comma y, and I'm going to rewrite that up here. So it would be x comma y. So now we just plug in what we know what x is and y is, and our answer is 6 comma negative 6. So if we were to graph these two lines, this is the point that they would intersect at. That is our solution. Now, if we take both of these if we plug in x and we plug in y into both of these equations, we would see that it would make this equation true. So I'm going to keep this answer right up here, and I'm going to just show you what I'm talking about because I think it's really important to know how to check your answer for this. So I'm going to keep the answer up here, but I'm going to erase this just so I can show you exactly what I mean for how to check your answer on this. Okay, so we solved it. Everything looks right. Now let's just double check that our answer is correct. And these are really easy to check. Once I can erase this. Erase. Okay. So now what I'm going to do is I'm going to plug x in. So remember, this is x and this is y. I'm going to take those values and I'm going to plug them into both of these equations. So the first one, I'm going to just rewrite it. I'm going to just write check. So we know that this isn't necessarily part of solving. It's just a way to check our answers. And instead of writing x, we got 6 for x, so I'm going to write 6. And instead of writing y, we got -6. So I'm going to write -6. And then everything else I'm going to bring down. I'm not going to change. So this -4 comes down, this -2 comes down, and this -12 comes down. So now we're going to just multiply these and see if this checks out. So -4 times 6 is -24. -2 times -6 gives us +12. Just bringing that down. And now when we add that, -12 plus 12, different signs, subtract to keep the sign of the larger, we get -12 equals -12. So this point works for this equation. So it's great that it works for this equation, but for this to be 100% the answer, it has to work for both of the equations. That's why it's important for us to check both of these. So now I'm going to just rewrite this bottom equation. And I'm going to substitute, same thing, for x and y, 6 and -6. Everything else stays the same. So we do that. Okay. Plus 8 equals 20. Let me just move that in a little. Equals 24. Okay, so same process. Let's multiply these. 4 times 6 is 24. 8 times -6 is -48. Oh, this is a -24. That's why. That should be a negative. There should be a negative sign in front of there. It's a good way to keep me on my toes. Okay. And then when we subtract this, we get -24 equals -24. So this equation, this point works for both of these. And notice how I kind of saw ahead, but I was like, okay, 24 minus 48 in my head. I was like, that's going to be -24, but this is a +24. There has to be something wrong. And that's when I noticed that I missed that negative sign. So that's why it's really important to check your work and to make sure that everything you're doing is correct. Okay, we're going to do one more example, but I'm not going to do the check part for that one. I just wanted to show you that this is how you do it, and I highly, highly suggest it if you're working on your own and when you're working on exams, especially region exams and other kinds of assessments. Okay. So we're going to do the same thing. We're going to solve the system of equations, and we're going to follow the same steps as in the previous slide. So hopefully you have them written down and you can refer to them very easily. So that first step is to identify your inverses. So remember, we're looking for the same variable with the same number in front, different signs. So in this case, it's this -y and that +y. Once we identify those inverses, we're going to add these equations together, and those are going to cancel out. Remember, additive inverses, when you add them together, you get 0. That's why they cancel out. If you want to put your 1 in front over here to make it easy to see, 1x plus 2x is 3x. And then when you add the 11 and the 19, you get 30. Okay, let's solve for x now. Very easy one-step equation. Divide by 3 on both sides. So we get x equals 10. So x equals 10. That's the first part of our solution. But we know that we have two variables here, and we need to solve for the other variable. So remember, you choose one equation, doesn't matter which one it is, and you're going to plug in what you just found for x into that equation. So I'm going to choose this top equation. So I'm going to just rewrite it here. We have x minus y equals 11. And now instead of writing x, I'm going to substitute that 10 in for x. So this just becomes a 10. But everything else stays the same. We still don't know what y is, so we still want to solve for that. Okay, so now we want to solve this equation. The next step would be to subtract 10 on both sides. That cancels. Bring down your negative y, so don't forget that subtraction sign with it. That's easy to forget. And then 11 minus 10 is 1. Our y is still not by itself, so there's one other thing that we need to do here. We need to divide by this negative 1 in front. That cancels, so we're left with y, positive y, equals 1 divided by negative 1, which is negative 1. Okay, so our last step here, write your answer as an ordered pair, which is 10, comma, negative 1. And just so you do know, I checked this on my own. So I took my own time, scrap paper, to make sure that this was the right answer. They're really easy to check, so I highly suggest that you check it. Okay, good luck.